Welcome to the breadboard tutorial. Today we're going to be talking about breadboard, some basic connections, measurement of current and voltage, and some additional tips and tricks in order to work with breadboards. The first thing that we need to understand about the breadboard is that the breadboard is just basically three connected metal strips under plastic. So under this, which you just kind of see for 5W, but under this you will see some metal connections that are going to dictate how each of these individual columns and rows connect. The first, these vertical or horizontal, depending on your perspective, lines are a single connection. So we go here and we see one, A, B, C, D, and E. That is a single metal strip, so that corresponds to what I'm calling a node, a single connection or a single point. We have these longer nodes, which are going to be called the power rail. There's positive and negative that we're going to be connecting batteries or other power supplies to later in the class. Those are all connected. So there's long red line on the top and the long blue line on the bottom. They're both connected and represent a single node or a single connection. The breadboard is mirrored across the midline, and that midline is represented by this little gap here. And that gap also represents a disconnection between this top column and this bottom column. So this A, B, C, D, E, as you can see here, are a single node, and this 8 down here, F, G, H, I, J, are also an independent connection. So this is a node, this is a node, and they're not connected between this gap. So they are individual connections. Basically, the takeaway for this is that if you have a single node or multiple of these holes in the same column, they're basically the same as a single or same point, electrically speaking. So components and devices are going to be connected to a single node and then spread out from there. The distance between the nodes doesn't matter. Current doesn't really care about distance, it just cares about continuity. So if I were to connect a component between these 2 points or even this farther point, it doesn't matter as long as they're connected and they close the circuit. It will all go well, so you don't have to worry about that. So let's actually go ahead and start connecting some of the components. So we are actually going to be using the Arduino as our primary power supply. You can see there that it has a 5-volt and ground, and that's what we're going to be getting as our source. So I'm going to go ahead and connect to 5 volts and to ground. And what we're going to do is I'm going to take the ground, I'm going to do this, and connect it to the blue here, and then take this 5 volt and connect it over here. Now, what I have done here is just create a connection for 5 volt in this red line and ground on this blue line. So only these two nodes are connected, which means that these nodes now are technically active. And let's say I want to connect a single resistor. I'll put up a diagram on the screen just so you can see what the circuit looks like. And one of the bigger mistakes that I need you guys to avoid is to connect components, what I call in the same node or in the same line, like this. Because what you're basically doing there is that you're connecting the component to itself. And current takes the path of least resistance, so it means it's going to skip the component. So if we want to connect a component, we're going to connect it horizontally in this case. I'm looking through the screen, so it's kind of difficult to see how to connect these things. What I'm going to go ahead and do is that in order for this component to be connected, I need to close the circuit. And the way that I am going to do that is connecting a wire from that red to that component, and then in order to close the circuit, I need to connect it to ground because the circuit is not complete if it doesn't finish it. So if I look at the circuit, I'm going to see that the power comes from the red, goes down this wire, and make sure to check that they're in the same node, goes through the resistor, and then goes up into ground and finish. And that is just basically my little race of electrons that are going from one point to another. And that is the basics of connection. If I wanted to add a second component in series, meaning back to back, a way to connect or think about a component in series is that the current is the same. So the current flows in both of those. So the way that I connect it is like this. And when I check my little current movement, I'm going to see that they come from the positive, goes through the first one, goes through the second one, and then back and close. And that is basically what a series connection would be. It would go from that end of the resistor to this junction, and then in this node, it goes from one resistor to the other, goes into this end, and then loops back. If I wanted to connect something in parallel, what denotes a parallel is that the current doesn't flow through, the current splits. And that is a good way to think about it when we're thinking about these connections, is the fact that in here, you're going to see the current go through both entry points of this resistor in this node. It's going to go through both resistors at the same time and then fall back into ground. And that is what we call a parallel connection. The important bit is that these beginning points and end points are connected into the same node, and the current at that point splits between the resistors, as opposed to in series, they actually flow through each of the resistors in series. So that concludes the basic breadboard tutorial on just connections.